What's happening, dogs? Mr. Allen here with everybody's favorite game show, Even, Odd, or Neither. All right, so even is not necessarily referring to an even degree function, right? Even function, we're talking about symmetry over my y-axis. Same with odd. Is it an odd function? We're not talking about its degree. We're saying, does it have symmetry with respect to the origin? So 180-degree rotational symmetry. And then neither would just mean that it doesn't have that symmetry, okay? So an even function is different than an even degree function. Odd function is different than saying an odd degree function. We'll continue with that in a little bit. Let's get after these tests. This is the algebraic test. So I want to see, is f of negative x equivalent to the original? If it is, it's an even function, all right? So we're going to have 3 and then parentheses negative x to the fourth minus 2 and then negative x squared. So I'm going to substitute in negative x in place of all my x's. And I'm going to have myself, let's see here, negative to the fourth, negative 1 to the fourth. That's going to be positive, so 3x to the fourth. And here I'm going to have negative 2. That's going to become positive again, so it'll just be x squared. Oh my goodness. Since f of negative x here is equal to f of x, it is an even function. Woo! All right, there we go. Now I could still do my odd test here. Let's just do it for practice here. So if I want to do my odd test, I'm going to do negative f of negative x. So I can just take my f of negative x, which was right here, throw a negative in front of it, put everything in parentheses, minus 2x squared. And now I'm going to have, let's see here, distribute the negative. I get negative 3x to the fourth plus 2x squared. No, that is not the same as the original, therefore it's not odd. But we've already decided that it is an even function, right? It's not going to be an odd function as well, but that would be our algebraic test for both there. Awesome, fantastic. So we'll always start, at least I'll always start, with my even test because I can use my even test in my odd test. So it just makes logical sense to go through both. All right, this next one here. So I've got negative 2x cubed plus x. So g of x is negative 2x cubed plus x. My hunch here is that it's got the potential to be an odd function since it's in both odd degree terms there, right? But let's go through our test. And I'm going to start with my even test, even though I'm pretty sure it's not. All right, so we're going to do g of negative x. That is negative 2, parentheses, negative x cubed, oops, boom, there we go, plus, and then we got negative x. Okay, so the negative x goes in for both. X is there. That's going to bother me. Can I get that? Yeah, gone. Okay. And now you just do my algebra, right? So we got, let's see here, negative 2. That's, well, the negative x cubed, that's going to retain its sign there. So negative negative becomes positive 2x cubed minus x. Is that the same as my original? No. So since g of negative x is not equal to g of x, it is not even. But is it odd, right? Is it odd? Let's find out, okay? I'll take my green one now. So is it an odd function? Well, I can take, let's see here, we got negative g of negative x. That's what we want to test. If that's equivalent to the original, then it's an odd function. So I can take my g of negative x, which is right here, throw a negative out front, and just toss this into parentheses here, and eventually distribute. But there we go. I've got the g of negative x, this portion here, that's in parentheses right here. Then my negative is my negative out in front. Cool? So that's why I like to do the even first, because I'm going to use it for my odd symmetry test. So now I have negative 2x cubed, and negative times negative is a positive x. That is the same as my g of x. So since negative g of negative x is equal to g of x, I know that I have odd symmetry, or it's an odd function. All right, there we go. It's relatively easy. It's not necessarily easy to tell. You can kind of have like a general idea if it's going to be an even function or an odd function when dealing with polynomials. It's not always so easy to tell with other functions that you don't even know about yet. You can do these kinds of tests with trigonometric functions, rational functions, any function really you can test using this. It's a little easier to tell with polynomials, but if they ask you to show it, you have to show these steps here to show that it is either an even, an odd, or neither, right? So kind of like in geometry, like proofs, you're like, I know they're congruent. You still have to show it, all right? Welcome back to the land of proofs-ish. All right, Last one here, h of x. I see we got we got a degree of 2 here. Maybe it's an even function, right? I've got a linear term. Interesting. We haven't seen a mix of an even degree and an odd degree. Let's see how this plays out. So first thing here I'm going to do is h of negative x. So I got negative x squared minus 5 and then negative x plus 1. And let's see here, negative x squared is going to become x squared. That's going to become positive 5x plus 1. That is different than this one up here. Only term that's different is the linear term, but not equivalent, right? So we got h of negative x does not equal h of x, so it's not even. But is it odd? It could be. We'll see. I don't know. Probably not. All right. Negative h. Oh, let me change markers here. Let me change markers. We'll go to blue. Negative h. Oh, that's cool looking mix of colors there. Negative x equals, well, I can take the h of negative x right here and throw a negative out front, x squared plus 5x plus 1. Distribute that negative, and I'm going to end up with negative x squared minus 5x minus 1. Well, now the only good term is my linear term that matches up to the original, right? Which is interesting, right? So our odd degree terms match up in the odd test. Our even degree terms seem to match up in the even test. Crazy. All right. In any event, negative h of negative x, or opposite of h of opposite x, is not equal to h of x. Therefore, it's not odd. It is neither. Yay. Look at that. It's like I planned it to have one even, one odd, and one neither, so you guys could see what each situation looks like. Honestly, I have to look this up sometimes where I'm like, wait, am I doing this right? Am I doing the right negative x? It's not a thing that we do frequently in mathematics, so if you feel the need to look it up every once in a while when it comes back up, don't feel bad. I have to look it up every once in a while. Like all of a sudden, it's been a year since I've tested for even, odd, or neither symmetry. I'm like, did I mix something up? I usually check it. So double check yourself before you wreck yourself. Hopefully this helps make sense of it. That's a lot of fun mathematics on that screen there, and you guys have a fantastic day.